Hello. My name is David Gageot. I work for Google in Paris, France. Who was there for my talk on Istio 2 hours ago? Cool. Thank you for coming back. So for the rest of you, I'm going to talk about container tools. Who's working with containers daily? Who's working with Kubernetes? OK, quite a few people. So like you, I work with containers. I try to containerize as much as possible, and I try to deploy it on Kubernetes. But there's an issue. There's an issue about the state of developer tools for Kubernetes. First, there's a lot of tools, too many tools. Most of them, they are very fresh, they're very new, there's a lot of bugs, they are moving very fast, but there's a lot of bugs. And also, I think that Kubernetes was mainly focused at ops at the beginning. And now we see more and more developers trying to adapt the way they develop applications for Kubernetes. And they maybe don't have the tools they'd like to have. The thing is, when you develop locally on your machine, everything is fine. You've got quick feedback loop. We've got fancy IDEs. We've got fancy frameworks, fancy tools. But as soon as you want to deploy your application on Kubernetes very often, then goes away your fast feedback loop. The problem is that the platform gives you more and more features. If you saw my talk on Istio, it shows you that Istio brings a lot of features that comes from the platform. But if you develop outside of the platform, you don't get those features. So that's really the state of the ecosystem of developer tools for Kubernetes. As I said, there's too many tools. I'm sorry, I'm going to present you more tools because, yeah, that's it. That's life. And all of those tools, they are open source. And all of them, they were started by Google, and we accept external contributors. So before I show you the tools, let me show you a small example of the problems that you're going to face if you develop with containers daily. So here it's a little bit of Go code. Who likes Go here? I know it's not, I mean, it's Devoxx, but there's a few people who do Go, right? So if I want to run my main application, it's just a hello world that says hello world every second, OK? And if you want to containerize it, you need to write a Docker file. Don't copy-paste that Docker file. It's not the best Docker file for this application, but it kind of works. So I'm going to do Docker build. I'm going to give it a name and a tag. And then I can do something like Docker run. And yeah, hello world. It works. So then I want to deploy it on Kubernetes. So Kubernetes, you're going to do some YAML. Who likes YAML here? Yeah, YAML, no? Yeah. You're gonna learn to hate it. But this is the simplest YAML possible to deploy this application on Kubernetes. So it's going to deploy a pod, and inside that pod is going to run my application in a container. So what I have to do is use the kubectl CLI, and give it this file. It says me that the pod was successfully scheduled on Kubernetes, but I need to make sure that it's actually running. It is running. And I have to make sure that it's actually my application that's running. Yes, it's running. So we deployed our first application on Kubernetes. That's quite nice. But because we are developers, we're going to change the code for the application. And we're going to do that cycle over and over again. Let me show you. So I'm going to say modify the world, Devoxx. So I changed the code. So now I've got to rebuild my image. Yeah, rebuild the image. Because I changed the tag for the image, I'm going to have to modify the YAML. Yeah. And then I'm going to have to send it again to the cluster. And I can show the logs. Yeah, my application is deployed. All those steps, you're going to do them 100 times, 1,000 times a day. Who likes that? Yeah, I like to do that every day. Yeah. So the first tool, this is for Hello World, right? So this is what I call the infinite loop of pain and suffering. And welcome, this is your new life. Okay? You're going to do that every day. Or maybe you're going to write some kind of bash script or makefile or whatever to solve the problem for you, for your project. And when you're going to add more microservices, it's going to be worse. So anyways, hello world is complicated. So the first tool I'm going to show you is called Skaffold. If you saw my talk on Istio, you saw me using Skaffold, but I did not really talk about it. Skaffold is a command line tool. You don't have to install anything on Kubernetes. It's just something you install on your development machine. It gives you fast iterative development on your machine. And it works very well for local development, remote development. For all my demo, I'm going to deploy my application either on my Mac with Docker for Mac. Docker for Mac. I don't know if you know Docker for Mac. Who knows Docker for Mac? Docker for Windows? Minikube, same thing. I said it already for the Istio talk. But basically, if you want to test Kubernetes on your machine, you install Docker Desktop, and you click here, and you've got a Kubernetes cluster running on your machine. I think you should try. So my demo will work locally, or I'm going to deploy some of them remotely on Google Kubernetes Engine. So let me show you Istio. Skaffold, sorry. So because we are in the world of Kubernetes, we're going to have to write some YAML. Yeah. So I'm going to have to configure Skaffold with YAML. But fortunately, Skaffold comes with an init command that tries to guess its configuration from the structure inside your project. So here I'm going to run Skaffold init, and it says, yeah, I found pod.yaml, I found a Docker file. The YAML says it needs that image, so I think the Docker file will build that image. Do you agree? Yes, I agree. So now I have my sources and Skaffold YAML, and I can do things like Skaffold build. Skaffold build, not very interesting. What it did is it rebuilt my image and tagged it. Okay. It chose a tag based on the Git tag on my project. If I'm on a commit, not on a tag, it will use the commit. If the workspace is dirty, it's going to have another heuristic to tag my images. But the fact is, I don't have to think about it. I develop, it's going to build and tag. Good enough. But I can do better than that. I can do Skaffold run. Skaffold run will build my image, tag it, take the new tag, put it inside the YAMLs, send the YAMLs to Kubernetes. Boom, it's deployed. But I can do better than that. I can also show the logs. So here with one command, I did the full cycle. Build the image, tag the image. It skipped the pushing because it's working locally. I don't have to push it. But if it had detected a remote cluster, it would have pushed the image. It tagged the image, changed the tags inside the YAMLs, and send the YAML to Kubernetes. And then it's going to stream all the logs from Kubernetes. Streaming the logs from multiple pods is already quite complicated in the Kubernetes world. So Skaffold does it for you. Who wants to use Skaffold already tomorrow? Few people? Okay. So I'm going to show you something better than that. Because you are developers, there's a dev mode. Dev mode, it does exactly the same, but it watches the file for changes. So that if, say, you modify a change, it will detect it automatically. It will rebuild only the images that are impacted by the change. It will tag only the YAML that needs to be changed. It will redeploy it and listen to the new logs. So now who wants to use it? Okay. So because Skaffold is a good citizen, when you Control-C, it will delete everything it's deployed. You can use Skaffold locally on your machine as a developer, or you can use it to deploy something in production. We're going to show that a bit later in the presentation. There's quite a few features in Skaffold, but the main feature is that it's the Skaffold dev. What's also very interesting with Skaffold is that it was not created for Hello Worlds. It works well with Hello Worlds, but it was not created for that. It was created for bigger projects. So let me show you a bigger project with 5 microservices. It's the same example I used for my Istio demo. It's a web application composed of multiple microservices. There's some Go code here. There's some Node.js. There's a few YAMLs to deploy the application. This is the scaffold configuration. What I'm going to do is I'm going to deploy that not on my machine, but on a remote cluster. Why do I want to deploy it on a remote cluster? Because I get more resources, I can schedule more services, I get more memory, I can have a bigger cluster. On my machine, I've got only one node. The problem is, if I develop locally and I deploy remotely, it's going to be more complicated. The cycles will be longer. And first, I have to guess which IP I need to connect to, things like that. So thanks to Skaffold, it's going to be exactly the same experience that you have locally. Because what it's going to do is going to watch the sources for all my microservices in parallel. For some microservices, it's going to rebuild the image and redeploy it to the pod. But some services like Node.js, Python, PHP, you don't need to rebuild each time you change something. So Skaffold will actually sync the files between my machine and the remote cluster. It will sync them live. And also, it's going to port forward all the ports for all the pods locally on my machine so that I can just connect on localhost. Let me show that to you. Scaffold dev. All the images were already built, so it knows it doesn't have to, oh, no, sorry. Wrong demo, I need to switch to a remote cluster first. This one, yeah. Just to make sure that I have 3 nodes on that cluster. Yeah, so scaffold dev. So it knows that the images were already pushed, so it's very quick to deploy, even if you have like 100 of microservices. You can see here that the logs for all the services are streamed, so you can really see the application working live. Yeah, almost. Come on. OK, it's going to be the first demo effect. We're going to try again. No, it should be OK, because it's doing port forwarding locally, so I can just connect on localhost. But that was very nice of you trying to help me. I'm going to delete. I'm going to do it again. Everything seems to work fine. You can see here the port forwarding working. I'm going to refresh. OK. Something is broken. Oh, sorry. Or maybe we can still see scaffold dev in action. So I'm going to change the HTML that's served by the Node.js application, just to show you that you don't have to rebuild the images all the time. Whoop. So it detects the change, sends it to the cluster, and oh, come on. OK, I know what's going on. Because I ran the application locally on my machine before. So because now it's trying to do port forwarding remotely, it's broken. So let me fix the demo for you. It's better when it works. So I'm going to switch back to local. I'm going to delete. So I told you, it's a complicated world. OK, so locally, I've got nothing running. It's all terminating. I need to switch to a remote cluster. I'm going to run a scaffold dev. For example, this port forwarding feature, it's very new in Skaffold. It was introduced very recently, so it could be the reason why it's not working properly. But basically, what you should see is when I change something, it synchronizes the files live with the running pods. And as a developer, you really don't see a difference if you work remotely or locally. Yeah. So this is the application. I need to see the hexagons. Yeah. OK, do it again. Ah, come on. Demo gods. Yeah. And you saw that even on my cluster, I've got a live reload set up. And thanks to port forwarding, it works as if I was working locally. The browser was refreshed automatically. So this is the kind of experience you'd expect with Skaffold. You just work on your code, and boom, it's deployed. Who wants to use Skaffold now? Yeah, okay, all of you. Monday, you download it. So that's Skaffold. It can build your microservices based on Docker files, but it also supports other tools to build your images, like Bazel and Jib, which are two tools I'm going to talk about. You can build locally on your machine using your local Docker, or you can build on the cloud, or you can build on any Kubernetes cluster. It's just a matter of configuring your Skaffold YAML. It can also run a few tests. Currently, we only support what we call structure tests, which are meant to test the structure of your images. Do I have the right file inside my image? Is it the right size? Things like that. And then Skaffold will deploy to your Kubernetes cluster using your usual toolset. If you're using kubectl, it's going to use kubectl. If you prefer to use Helm, you can use Helm. Who likes Helm? OK, so if you like Helm, you can configure Skaffold to use Helm. The idea is that you keep using the same tool that you like, and Skaffold will make it more enjoyable. I think it's a good trade. That was Skaffold. Talking about building images, you've seen my demo. I do Skaffold dev, and then I change something, and it's quite quick to rebuild the image. But in reality, it's maybe not the case. Maybe your images are too big. Maybe you didn't even know which base image to choose. Maybe your build is too slow, so that when you change something, it takes a lot of time to rebuild. So I'm going to show you a few tools that can help. First, let's talk about base images. Yes, base images, but before first, we're going to talk about multi-stage build. Who knows multi-stage build in Docker? So if you don't know it and you're using Docker and you're writing Docker files, you should take a look. The idea is that instead of having only one from line inside your Docker file, you can have multiple. Each of them will be stages, and each stage produces artifacts that can be used by later stages. So the idea is that, for example, here, I've got a first stage where I use a Golang image, or I could use a Maven image with a lot of tools. I would copy the sources from my machine to that stage. I would build them to artifacts, and then those artifacts, I can copy them to a second stage where I don't need to rely on the big base image. I can rely on a smaller one. Like here, to build, I need Golang. To run, I just need a small Alpine. Okay? So with multi-stage build, you can really have smaller images that better use caching mechanism in Docker. And also, you've got more freedom to choose your base images. Because for build, most of the time, you don't really have to choose. You take the one that has the tools you need. But for the run, I've seen a lot of companies spend 6 months trying to build their own base images. So while they do that, you just write a Docker file, and at the end, you're going to switch this image, right? So you should really use multi-stage builds. So let's say you're using multi-stage builds, and you want to choose your base image. Who's using Ubuntu, Debian, the usual base images? Yeah. Alpine, maybe more, yeah. So here's another set of base images you can use, Distroless. So Distroless, it was created by Google to make your image smaller and more secure by default. The idea is that an image you built with Distroless is going to contain only your app and its runtime dependencies, nothing else. There's no shell. There's no package manager. There's nothing. Okay? It's just the minimal Linux distribution. In fact, it's Distroless that you can have to run your applications. Because basically, what you need is your application, its dependency, and nothing else. If you're running Java, you need JVM and nothing else. So this is Distroless. This is a set of images you can use. For example, this is Distroless base. This is the smallest one. There's only a libc, glibc, SSL libraries to do SSL. There's a root user, temp directory. That's it. No package manager. You cannot install tools using Distroless. How easy it is to adopt? You just have to take your Docker file and change this base image here. That's basically it. Okay? Boom, I'm done. I'm going to build. And I'm going to run. Yeah, done. I migrated to Distroless. And now I've got a more secure image with fewer components inside the image at runtime. If you're using Google Cloud, there's a chance you're already using Distroless images for some of our products. But it also works for Java. Who's a Java developer here? Yeah, more than Go developers. So I assumed. So I added that for you. So this is a demo of Distroless Java. So this is base plus a JVM, and that's it. And I think I've got a Spring Boot application somewhere. Yeah. So here, I'm going to just use this, and that's it. I can use any base image to build, but for the run, I'm going to use Distroless. That's it. It works, and I can run it. Spring Boot, yeah. So that's very easy to adopt, okay? And Distroless is for a few languages like Node.js, Java, all the statically compiled languages like Rust and Go. You can use the base image. It's open source. There's not a lot of choice in terms of images. The idea is not to compete with the hub, Docker Hub. It's only to have a few base images for a few well-defined languages. If you really need to debug inside your containers, you might want to use the debug flavor of each of those images. It's the same plus a shell, because sometimes it's very convenient to connect to a shell in a running pod. Okay? It's very easy to adopt. You should give it a try if you like it or don't like it. It's quite easy to try. Another big problem, maybe bigger than base images, is the fact that building images over and over again when you do a small change can be very long with Docker. Okay? Let me show you the same Spring Boot application. I'm going to build it locally on my machine, maven package. So because it was built already, it's quite quick. If I change a dependency, like the version of Spring Boot, it will download only the jars that it has not downloaded already, because the rest is cached somewhere on my machine. Okay? This is something you'd expect from Maven or Gradle. Now, I'm going to build that with Docker build. Docker build, you run it. If you've run it already, boom, very quick. Okay? But what do you think will happen if I change the POM XML? What do you think if I add a comment here? And I do a Docker build. Someone has an ID? I'm going to, sorry, what? The layer hash will be wrong. Yes, so I'm going to rebuild the application from scratch, but I'm going to re-download all the dependencies. I mean, I did not change the dependency. I just added a comment. But because Docker is working with layers, and each time you have a layer that it has already seen, it can take the result from the cache. But each time you change something that's used in a layer, and you change one bit, the rest of the build has to be done again and again and over again. So here, I changed the POM XML. I can change anything. I can add a space. It has to re-download all the dependency and rebuild my application. Let me show that to you. I'm not going to do it because it's like 2 minutes or maybe 4. Maybe even, yeah, it's going to re-download everything. So I see that every day with Docker build. You can trick the system. For example, here, I copy the POM and run a command, and then I copy the sources and run a command, so that if I change the code, it will not re-download everything. It's only if I change something in the POM that it will re-download everything. But there's a limit to that system. You cannot do better than that. Okay? Who has seen that already? That you change something very small and it takes a lot of time to rebuild. So this is not something you can fix with Docker build. There's other tools, but not Docker build. So I'm going to show you 2 tools that you can use to fix that issue. One, I'm not sure you're going to adopt because it's really complicated. It solves really complicated problems, but I think it's interesting to know. It's Bazel. Who knows Bazel? So for the rest of you, Bazel is the open source version of Blaze, the tool we use at Google to build our monorepo composed of 3 terabytes of sources. It's like we use Blaze all the time. Everything you need to build is built with Blaze. So Bazel is the same. It's a very extensible build system that's truly incremental, that supports any language, and you can use it on your machine to have a very fast and precise, reliable build. Oops, sorry. Okay? And Bazel has plugins, so you can use the Bazel Docker rules, open source too. The Bazel Docker rules, if you have an application that's built with Bazel, you can just use that rule to produce a Docker image at the end. And the fun fact is that you don't even have to install Docker on your machine. Bazel will build Docker images without using Docker. Because, in fact, a Docker image, it's just an archive. It's a tarball. It's an archive with files and JSON files and your files, and every tool can produce that. So that's exactly what Bazel is going to do. It's going to produce an image directly without using Docker. And it's going to base those images on Distroless. So if you build Java, it's going to use Distroless Java. If you build Go, it's going to use Distroless Go. Base, sorry. The problem is that you have to forget everything that you know about your build system. For example, here, I've got the same Spring Boot application. You don't see a POM XML because I trashed it. Okay? I had to redefine the whole build using Bazel syntax. So I've got a build file, I've got a workspace file with all my plugins, all my dependencies. So forget about that for a second and see what it does. I can then run Bazel build. It's not going to run inside a container. It runs on my machine. It can have a very good cache of all the artifacts it downloaded on my machine. And then it produces an image at the end. If I change a dependency like Spring Boot, and I rebuild, it's going to re-download only the jars that it needs, because the rest, it's got it on my machine, okay? Come on, yeah. So few jars, boom, we're done. Building the Docker image. Should be quick. Should be. Yeah. So it's still not very quick, but it's much quicker than with Docker build, okay? And it can scale to a lot of projects, a lot of languages. There's companies like Dropbox who use Bazel, and they love it because they build software with different languages. But I don't think you're going to adopt Bazel tomorrow, but maybe you can give it a try for a small project. Another thing you might want to adopt, it's very, very simple to adopt, and I think, like Scaffold, you're going to want to use it tomorrow. It's called Jib. Who knows Jib? A few of you. So Jib, it's basically a Maven and Gradle plugins, and Jib can build Docker images without Docker, same as Bazel. You don't need to write a Docker file. Cool, I don't want to learn that. And it supports basically every language in the JVM, okay? It's going to create an image from your POM XML or Gradle file. So it's very simple to adopt. Let me show that to you. With the same example, Spring Boot, all I did is I changed my POM XML to reference the version of Jib that I want to use, okay? This one was released yesterday or a few days ago. I can set a few options if I want, but by default, it's going to use Distroless as a base image. And if I run maven, and I run the Jib build command, it's going to build my application, compile the sources, and create a Docker image at the end, and push it to a registry with the name I gave somewhere on the command line. Yeah. Okay, on command line here, I gave the image name. So you don't have to learn Docker files. You don't have to do anything. You don't have to learn a new tool. You don't have to learn Bazel. You're going to have a build that's incremental, reliable, and it's really the best of both worlds. And we'd love to see these kind of tools implemented for other languages at Google. But first, Java developers, you can use Jib. Who wants to use Jib tomorrow? A few, yeah. You should try. So if you use Maven or Gradle, doesn't care. You can use both of them. It's really, really nice. You can tweak a few parameters, like you can change the base image. If you don't want to use Distroless, don't use Distroless. It's the default setting. You can use Adobe JDK, Azure, the new JDK from Amazon, whatever. You can set JVM flags also. Maybe they're going to be set automatically in the future, but right now you have to set them. So one thing that is nice also is that Skaffold knows Jib. So when I do a Skaffold file and I've got an artifact, I can say, hey, by the way, this should be built with Jib. So that when I do Skaffold build, it's going to run Jib for me. So once again, I use the same tool, Skaffold build, Skaffold dev, Skaffold run. I don't have to even run Maven. Who likes that? Yeah? A few people? Cool. Oops. So that's Jib. You should try it on Monday. You're going to love it. I've got 2 more tools to show to you. They're a bit more advanced, maybe less for the developer, but could be. One thing that happens very quickly when you build microservices is that you don't have enough power on your machine to build all the services, okay? You have Docker for desktop, but at the end of the day, you have like 10 or 100 services to build, and you wish you could use a cluster to build your images. You're going to deploy them on a cluster. You could use a cluster to build them, right? But it's quite hard to set up. You need to install GitLab or Jenkins. Who's using Jenkins here on the CI/CD? GitLab? Hey, more Jenkins than usually. The thing is, if you install Jenkins or GitLab, very often you have to choose, do I need to, on my agents, do I need to bind the Docker socket or use Docker in Docker? You don't want to know. Both choices are not good, okay? Both choices are not really secure. Both choices are not really quick. And also, it's quite hard to set up. Also, one thing that's going to change in the future is that if you want to run Docker build, you need Docker, the real product by Docker, the company. If you want to run Kubernetes in the future, you might run it on something else than Docker. In fact, right now, you can run it on Containerd, you can run it on other runtimes, and all those runtimes, they don't support Docker build, this command. They support Docker containers, but not the build part. So if you want to build your containers on a cluster, right now, it could work with Jenkins and GitLab. Maybe in the future, it's going to be broken. So we came up with one tool called Kaniko. It's a small binary that basically replicates Docker build. It will take your sources, it will take a Docker file, and it can produce an image out of it. And it can run as a pod on your Kubernetes cluster. I'd let you think about it. The idea is that you've got a cluster, any cluster, you can just talk to it and say, okay, I'm going to run this pod running Kaniko. Here's my sources, here's my Docker file. Please produce an image and push it. So that you can use any cluster, and if it's a big one, it's going to be better to build a lot of microservices. Let me show that to you with Skaffold. So I configured Skaffold. I added a profile in Skaffold to build my images not locally, but on a Kubernetes cluster. So here I said, for the build, please use Kaniko. And at the end, you can use that secret to push the images to registry for me. Okay? So that if I do Skaffold build, and I activate Kaniko profile, what it's going to do is going to take my sources, create a tarball out of it. It's going to send it to the pod running on Kubernetes. It's going to start the pod, and the pod is going to build my image for me. So it's going to be slower than if I run it locally, but I can run a lot of builds in parallel. Okay? So for just one service, maybe you should stick to building locally. If you have plenty, you can try with Kaniko. It will basically build the same thing that was built with Docker build. On newer version of Kaniko, we have better caching system, which should make it faster, but the idea is the same. Any Kubernetes cluster can build your images. Come on. I'm going to wait, count to 5. Should be OK. Demo gods. OK, so I'm going to try to make sure. So the remote cluster pushed my image somewhere. I can just Docker pull it. And yeah, it's coming. And I can maybe run it. Yeah, hello world. That was a bit long for hello world, right? But it's going to be better and better with future version of Kaniko. The thing you need to remember is, thanks to Kaniko, you can use any Kubernetes cluster to build your images. So that's very good for the CI/CD if you have plenty artifacts to build. Other tools like Knative. I don't know if you know Knative. It's building blocks for serverless that were announced by Google in July. And they use Kaniko to build your images. So that at some point, you won't even know what's building your images. It's just building on a cluster. The last thing I want to talk about is I want to talk about YAML templates and multiple environments. Who needs to deploy their application on multiple environments, like staging, production, dev? Who likes that? Yeah, someone, 2 people like that. You like YAML templates, right? Yeah, YAML templates. So if you have YAML to deploy your application on Kubernetes, and you want to specialize your YAML for multiple environments, you're gonna end up using tools like Helm, and you're gonna introduce templating inside your YAML. Do you think it's easy to read? Not really. This is an extract from Istio installation procedure. The thing is also, with your YAML, if it's got a lot of templates inside, you cannot use it without the templating tool. You cannot use it without default values. So it's really a nightmare. I can send you YAML, and you're like, cannot use it. How can I specialize this YAML without this tool? Or let's say I give you a YAML, how can you run it on your machines and just change a few values? This is where Customize comes. Oops, sorry. Customize is a nice CLI that you can use to customize your YAMLs. So the idea is you're going to write a lot of YAML files, and if you want to specialize them for some environment, you can use Customize to do that. It's going to apply patches and overlays on top of your YAML. It's going to deal with secrets, config maps. So let's say you have like SSL certificates that are different in production or staging or pre-prod. Customize will do that for you. Let me explain how patches and overlays work. Let's say you've got this YAML. This YAML is the deployment for my hello world, okay? In production, I'd like to change only this value here. Just world. I don't want to introduce templating here. I don't want to do something fancy. I just want to give this YAML to anybody. Anybody can use it. And I want to be able to just change one value. I'm going to do that with a patch file. A patch file is basically, I keep the same YAML, but I remove all the things I don't want to change. But I still need to reference the object that I want to edit. So I'm going to edit the deployment, who's spec as a template, and the container hello, I'm going to change this value. So the patch, then, of course, you remove the white lines. And if you apply the base and the patch, it will give you something like that. Yeah, same YAML, but with one value that is changed. And you can apply multiple patches, and multiple patches create an overlay, and then you can have an overlay and multiple overlays if you want. It's quite easy to do, a bit complicated to explain, but quite easy to do. Let me show that to you in action. I've got the same hello YAML I showed you. I created my patch to change the greeting. I created another patch to change the image pool policy in production. I want to make sure that I always have the latest version of my images, so I'm going to patch that in production, but in development, I don't want to do that. How do I make the link between that and those 2 patches? I create a customization file. Customization file is something that Customize will use to link your base YAMLs and your patches. So I say, okay, here are my patches, here are the dev YAMLs I'm going to use. They are the same that in development. In development, I use this YAML, okay? And I can change a few things also on all my YAMLs at once, like setting new labels or changing the namespace, things like that. And it's quite easy to then create the specialized YAML. You just have to run customize build with the name of this configuration here, and here you have your specialized YAML. So compare it with that. Okay, you can see that on the right, you've got the development version. On the left, you've got production. So we have a different image pool policy. We have a different value for this environment variable. We have additional labels, and the namespace was set to default. It was changed, but I kept default for my demo. Okay? Do you see that? Do you think it's easier to use than Helm or more complicated? Who think it's easier? So it does not solve all the problems that you solve with Helm, but the thing of specializing your YAMLs, it solves it very efficiently and very easily and very nicely, and it does not break the original YAMLs. So it makes it very easy to distribute your YAMLs across multiple teams, and each of them, they might apply their own layers. And of course, it's integrated with Skaffold, so that if with Skaffold I want to use a different overlay in dev or in prod, I can just use profiles, so that if I let me switch back to local. Locally, I can do something like scaffold run. Okay, it's going to say hello world. And if I switch to back to production, I can use scaffold run, and I can activate the prod profile that's going to use customize, and we should see hello production, hopefully. Come on. We think it's going to work. Yeah, it's going to work. I'm sure it's going to work. Come on. Yeah, production. Oof, it works. So we specialize our YAML for production environment. We can add more YAMLs only in production. We can change secrets, config maps, properties, things like that. It's very easy to use on a daily basis. Who wants to stop using Helm and use customize? Maybe fewer people. Yeah, one. Okay, you're my new friend. Okay. Not a lot of people know customize, but it's really a very simple tool that solves one problem, and it solves it well with a good design. So that's customize. Handle different environments. It interfaces nicely with Skaffold. You understood that Skaffold connects all the dots between all the tools I showed you. And to sum up, all the tools, if you want to capture one slide, it's the one. So customize makes it possible to handle customization for different environments. Kaniko will build images on Kubernetes. It will build them in a secure manner, no matter which runtime runs underneath your Kubernetes cluster, and it does not require complex setup. You can use Jib to build Java images. This, I think, you should try on Monday. Bazel offers truly incremental build that produce Docker images at the end. I think it's really a tool that you should be aware of, but it's maybe too complicated for you to adopt on Monday, maybe on Tuesday. And Distroless will give you more secure images, and Skaffold, I showed you, connects all the dots between those tools, and you can use it in development and also in production. Thank you very much. I hope you liked those tools. If you like them, or if you don't like them, you can contact me on Twitter, Instagram, GitHub, DGAGEOT. We're looking for feedback on all of those tools. So if you're using those tools, or if you don't use them because you don't like them, please say that to us. Also, I've got a message for you. If you go to the Google booth and you play the Code Labs and you try to win prizes, you need this secret word to go to the last step. Okay, if you want to win the bigger prizes, you need the Camulox. Say Camulox, or everybody say Camulox. Okay, so you're ready to win the bigger prizes. Thank you very much. I'm open for questions. No question? Oh, everybody's leaving. Yeah, one question.
Are you able to swap one pod from a remote cluster?
Am I able to swap one pod on a remote cluster?
Same as you can do with
So why do you want to swap a pod, sorry?
replace one remote pod with your local.
Oh, you want to replace a remote pod with something that runs locally, like telepresence. No, this is something we want to do with Skaffold. It's not something we support yet. But the idea is that the more microservices you're going to have, the more you're going to deploy on a remote cluster, but still you want to keep the local experience. You don't want to push images. So that's something we really want to do in Skaffold. It's not there yet. Other questions? Yeah? Is Kaniko able to use caching for everything it does? Kind of. So what I showed you was a Kaniko build without any cache. In the latest version that was released a few days or weeks ago, it can cache the images that it pulls. but then it's really a build that does not use a cache for now. But it's something we're gonna add in later version of Kaniko. We want Kaniko to be faster than Docker build. Another question? No. Okay. Thank you very much. Have fun.